Welcome. This video goes over sections 9.1 and 9.2, which is area and circumference, including some polygons as well as circles. So we're going to start off, we're actually going to skip over the triangle here to our parallelogram. Hopefully we already know how to find the area of a rectangle. Rectangle, we can clearly see what it looks like, so we could actually split this up into the 2-meter blocks by 3-meter blocks, and you can actually see that there are 1, 2, 3, 4, 5, 6 square meters within that rectangle. So to generalize that, we can take the base of the rectangle times the height of the rectangle to get its area. So here we would just do 2 times 3, which would give us 6 square meters. Remember, when we're talking about area, we always want to use those square units because we're looking at this is 1 square meter. It's a meter by meter square. Okay, we can utilize the same thing to find the area of a square. Square is just a little bit more specific of a rectangle. If this is 7, this is also 7. So our area here would be 7 times 7, or 49. And these are centimeters, so square centimeters. And again, we could draw in the 7 by 7 and see those clear 49 square centimeters. Okay. Rectangles or squares are both specific types of parallelograms, and because of that, we can actually apply the same base times height formula for any parallelogram. If you look at a general parallelogram, right, we could put in the base and the height. The important thing here is remembering that the height is not necessarily a side of your parallelogram, rather it's the perpendicular distance from one side to the other. So if this is your base, this is your height. However, this could also be your base, but then your height would be this distance here that's perpendicular to that side. So if we're looking at a parallelogram, we could look at taking this triangle here and moving it over here. And now this resulting shape here is just a rectangle. So we can utilize that same formula of base times height, remembering that height always has to be perpendicular to the base. Okay, so we could use that to find our area here in our nice little parallelogram. We'll skip over to number 5 here. We'll come back to number 4 in a second. So we know that this is 6 centimeters and this is 5 centimeters. This is a very out of proportion drawing, so just ignore that for now. But we're looking at finding our area. So we're going to be looking at the height, which is this guy here. So since that's not given to us, we're going to use this little right triangle here and say that 2 squared plus the height squared is equal to 5 squared. Okay, so that's 25 and 4. 25 minus 4 is 21. So your height squared is 21. So your height is the square root of 21. So your area is going to be the base, which is 6 times the square root of 21. Okay, and we could see if we could simplify that radical. In this case, 21 is 7 times 3, so we could leave it like that. If we wanted exact form, it would be 6 root 21 square centimeters, or we could actually figure out what that is using our calculator by doing the 6 times the square root of 21. And we get that the area is about 27.50 square centimeters. Okay, so area for a parallelogram is just base times height. We can utilize this algebraically as well. So if I know that this distance here is x plus 2 inches and my total area is x squared plus 5x plus 6, we can use our base times height to say that my base, which is x plus 2 times my height, is equal to the area, which is x squared plus 5x plus 6. Right? So now we need to reach back into some algebra tools that we should already have to be able to find what this height is here. So we know we need to get rid of this x plus 2. It's a factor here. So let's go ahead and factor this x squared plus 5x plus 6 to see if we can get that common factor there. So we're looking for 2 things that multiply to be 6 and add to be 5. So that's 2 and 3. So this factors to x plus 2, x plus 3. If you're not confident in that, just take a little second to multiply x times x is x squared, plus 3x plus 2x, which is 5x, plus 6. seems to work just fine. And then we get this x plus 2 times h. So now we can clearly see that we have this factor here of x plus 2. So if we divide out an x plus 2 on both sides with that h by itself, 2, we get that h is equal to x plus 3. And again, we want to make sure we're still using units. H is this height here. So we're going to be in inches. Oh, and this should be here in inches squared with our area. So our height is x plus 3 inches for that parallelogram. Okay, now backing up to our triangle here, we looked at our parallelograms first because our parallelogram is very related to our triangle. So we want to understand why these formulas work, not just have a formula that we have to memorize. So if we look at a triangle, if I take this same exact triangle that we have here and just reflect it over and spin it around here, we can take that exact same triangle and just stack it on here. So this one triangle here that we're trying to find the area of is equal to half of this whole parallelogram. So we already know how to find the area of a parallelogram. It's base times height. So the area of a triangle is 1/2 of base times height. Okay, keeping in mind that base is any side of your triangle. The height is the perpendicular distance from that side to the opposite vertex. So that can be any way you have your triangle oriented. It doesn't have to be the bottom. This could be the base of your triangle, but then your height would be this perpendicular distance to the opposite vertex. And so let's take a look at a triangle here. This is a right triangle. So right triangles are really nice because your base and height are just two sides, because this is the perpendicular distance from the side to this vertex. So we will just have base times height and 1/2 of that, right? We could think here, if I put in that second triangle, I'd get actually a rectangle here, which is just base times height. So we have 1/2 of that base times height. So that is 4 times 3 is 12. 1/2 of 12 is 6. We're not given units here, but we still want to make sure that we identify that these are square units. So if you're not given a unit, we're just going to say units squared so that we know what we're dealing with, those two-dimensional units. So let's move along here to some trapezoids. So a trapezoid, again, we're going to try and relate it back to a shape that we already know. So the best way to do that for a trapezoid, there are multiple ways, but the easiest way to see it is if I slice this trapezoid right here down the middle, if I flip this piece over here, it is going to end up looking like this. So we end up with this long, skinny parallelogram. Could be a rectangle, doesn't have to be. Where this has been flipped over here, so this is base 1 right there, and our height has been chopped in 1/2. So this is 1/2 of the height. So then we can just utilize our parallelogram formula again. So it's just base times height, but the base of this parallelogram is this base 2 and base 1 together. So that is base 1 plus base 2, and then the height of this is 1/2 of the original height of the trapezoid. You might see it like that. It might be rearranged. Remember, multiplication is commutative, so it might be 1/2 base 1 plus base 2 times height, or however that looks. And it doesn't matter which one's base 1, base 2. Those subscripts just tell you that they are not the same, right? They have to be different to be a trapezoid. Otherwise, it's just a parallelogram. However, you could use that per parallelogram and it would still work. So if we want to find this area of this trapezoid, again, we're going to think about cutting it in 1/2. So this is 1.5 inches. We're flipping it over here. So this is 1.4 inches, which means this whole base of my parallelogram is 4 plus 1.4, which is 5.4 inches. And then we are going to, that's our base times our height, which is 1.5. So 5.4 times 1.5, and we end up with 8.1 square inches. Okay, and again, we could just plug that into the formula if we wanted to, but again, that's one more thing you have to memorize. But if we wanted to, we would have 1/2 4 plus 1.4 times 8. And if we do that same thing, 1/2, 4 plus 1.4 times 8, we're going to get the wrong thing because I typed it in wrong. Because that's a 3. 1/2, 4 plus 1.4 times 3, and we'll end up with the same 8.1. Helps if you use the correct numbers. So let's take a look at one more. We have a trapezoid. We're trying to find the length of one of the bases. So we're looking for a different piece of information. If the area of the trapezoid is 12 square feet and the height is 4 feet and base 1 is 3.5 feet. So this was a good one to go back to what is the formula, and then we're going to use our algebra to work backwards to find what base 2 is. So I know the area is 12, so my area is equal to, and again, it doesn't matter what order you put these things in here, you're going to end up with the same thing. So I'm going to use that top one. So we have base 1, 3.5, plus base 2, that's what we don't know, times 1/2 times 4. That doesn't necessarily need parentheses, but we can put them there as well. So 1/2 of 4 is 2. Then we have two options here. We can distribute that too. That would be one option, or we could divide out that 2. Since our goal is to get base 2 by itself, dividing off the 2 actually helps us get there a little faster. It's not wrong if you want to distribute it. You definitely can. So we get 6 equals 3.5 plus base 2, and then subtract 3.5. So base 2 equals 2.5. And then make sure you put in the correct units. The base is a length, so we're just going to be using length units, which in this case are feet. So it's 2.5 feet. Okay. So when we're looking at this, that wouldn't be a bad idea to go back and check your answer. So if I take 3.5 plus 2.5 times 1/2 times 4, I should get 12. Okay, if you want to put the correct area working forwards, then go back and fix your algebra. Hey, so we have a couple more shapes. We're going to look at rhombuses and kites. And if you remember back to our unit on quadrilaterals, we're going to utilize the fact that in a rhombus and a kite, the diagonals are perpendicular to each other. So that will help us, again, going back to what type of shape can we make from it. So if we chop off this piece here and move it over here, we end up with this lovely parallelogram. Hey, we already know how to find the area of a parallelogram. It's base times height. So we just have to figure out what are the base and what are the height of that parallelogram in relationship back to that rhombus, or this works for kites as well, since their diagonals are perpendicular. So the base of this, we're going to use this as the base because we already know this perpendicular distance here. So diagonal 2 is the base, and the height is this, which is 1/2 of diagonal 1. Most likely you will see the area formula as this. Remember, excuse me, not multiplication is commutative, so these are equivalent things. We don't have to take 1/2 of diagonal 1 or 1/2 of diagonal 2. Right? It's all multiplication. It doesn't matter what order you do that in. But we can always go back to, it's just a parallelogram rearranged, and find those pieces in relation to it. So what is the area of a rhombus that has one diagonal with a length of 6x plus 4 inches and a second diagonal with a length of 10x plus 10 inches? So we're just going to use our area formula here, that it's 1/2 of one of the diagonals times the other diagonal. Okay, so again, this is all multiplication, so how you do it is completely up to you. I'm going to distribute this 1/2 first. So we get 3x plus 4 times 10x plus 10. And then remember, if you have binomials, we need to multiply everything times everything. So we're going to take this 3x times both things. So 3x times 10x, 3 times 10 is 30, x times x is x squared. 3x times 10, 3 times 10 is 30, and then we just have that x there. And then we also have to distribute the 4 to everything. So 4 times 10x is 40x, and 4 times 10 is 40. Okay, combine any like terms we have here, which is just this 30x and 40x. So we get 30x squared plus 70x plus 40. And we want to keep in mind this is an area. So what are we looking at? This is inches squared. So our area there is that polynomial, and that's the information we have for it. Okay, last but not least, we are going to look at some circles. So circles are a little different. They're not polygons. So we have some different dimensions that we're going to be using. Particularly, we're going to be focused on the radius, which is the distance from the center of a circle to any point on the exterior of a circle. Definition of a circle are all the points that are equidistant from some point called the center. So when we're looking at finding the area of a circle, it is a little harder to picture what it looks like. You can actually make a circle into a rectangular parallelogram or an approximation of one, but we won't go into that in detail here. So our area for a circle, we're just going to remember is pi times the radius squared. Oftentimes people get the area and circumference confused because they both involve pi, they both involve the radius sometimes. Keep in mind that area is a two-dimensional thing. So we have to be multiplying two dimensions. In this case, we're multiplying radius times radius. Pi is not a dimension, it's a number, right? It's a constant. The radius is that dimension of your circle. Whereas circumference, which is the distance around the outside of the circle, is pi times the diameter, or 2 pi times the radius. So here we only have that one dimension. It's a length, it's not an area. So let's look at utilizing these things. So the first thing we're doing is finding the area and circumference of the circle. Leave your answers in terms of pi. So what this part here means, leave your answers in terms of pi, is that we're going to give an exact answer. So anytime we utilize pi, we're going to end up with some sort of decimal that we'll have to round, since pi is irrational. So by leaving pi as part of our answer, we can avoid having to round our answer a lot of times. So here we have our diameter is 12, which means that our radius is half of that. So if we are going to find the circumference, you need to either use 12 times pi or 2 times pi times 6. Either way, we are going to get 12 pi, and our units are length, so it's just centimeters. So this is what it means by leaving your answer in terms of pi. We're going to have that pi in your answer. If you were not going to have pi in your answer, you would just actually multiply that out. 12 times pi, which is approximately 37.69911. But you can see that here we're going to end up having to round that answer. So the nice thing about leaving it in terms of pi, 1, you don't need your calculator to do that. And 2, we can have that nice exact answer. Okay, our area here is going to be pi times the radius squared. So 6 squared is 36. We get 36 pi. Again, it's just multiplication, so we can move that pi to either side. And then our units here are square centimeters. And we're going to work a little bit backwards on this next one. We're finding the radius for a circle that has a particular circumference. So if we know that circumference is 24 pi, that means 2 times pi times the radius is equal to 24 pi. So we're just working our way backwards to figure out what r is. So here we're multiplying r by 2 and by pi. So we can divide both sides by 2 pi. Okay, pi divided by pi is just 1, so that goes away. 24 divided by 2 is 12. So we get that our radius is 12 inches. Okay, and if you worked back into finding your circumference, it should get the same answer. 2 pi times 12 is 2 times 12 is 24. We get 24 pi inches. Last but not least, we're looking at the circumference of a circle that has a particular area. So to get our circumference, we're going to need that radius. So if I know that my area is 9x squared pi, that needs to be equal to pi times your radius squared. So again, our goal is to get the radius by itself, and then we can use that radius to find the circumference. So if we work our way backwards, we're trying to get that r by itself. So we're undoing our operations in the reverse order we would do them. So get rid of the pi first. So we get 9x squared equals r squared. And then take our square root. Hey, we know how to do that. R is the square root of 9, which is 3, and the square root of x squared, which is x. So our radius is 3x, but don't forget, we're not done. We're going to go back because we're asked here to find the circumference. So we have 2 pi times 3x. Simplify that as much as possible so we can multiply the 2 and the 3. So we'll get 6x pi, and then our units, these were square centimeters. So our circumference is just centimeters. So that is all for this video. Lots of areas and some practice with some algebra. So thank you for watching.